Hey everyone, welcome to the channel. My name's Nader. This is a follow-up video, which is part 2 to the Blackjack introduction video, which I posted previously. If you haven't seen the requirements or some tips I posted on how to actually get this Blackjack project done in JavaScript, I encourage you to check out that video, because in this video, we're going to go look at the actual implementation in JavaScript of how to actually put this into code. So that said, let's get right into it. So you can see I have the requirements up on the screen. I just want to quickly go through these again, just so that we're kind of on the same page. And I'll just go through kind of the tips really quick, just to make sure that we kind of have a good outline ready for us to actually code out together. So here are the requirements. We wanted to generate a deck of 52 cards, 2 through ace with all 4 suits. Then at the start of the game, we wanted to kind of deal 2 cards to each player, the player and the dealer. Then we wanted to kind of go through this game loop right here, where we're dealing cards to the players and checking to see kind of what scores they have based on this point breakdown that we have here. We also have a bit of logging to do, which I have listed out over here, but we'll kind of deal with that as we kind of go. So with that said, I had a few tips that I listed in the previous video, and it's worth noting kind of again that there are many ways to do the solution. I'm just going to go through one solution that I personally came up with. What you're not going to see is me make too many crazy amount of errors or kind of go back and forth too much with debugging because I already kind of went through that. So it's important to note that you will have experienced that yourself. So while it may seem like I'm just kind of like cramming through this code really quickly and like have perfect code from the start, that's definitely not how it worked. I had a lot of bugs and errors as I was kind of trying to figure out the best way to actually approach this problem in a simple enough way to kind of explain here. So don't worry if you ran into a lot of issues. I'm just going to take out all of the errors and we're going to go through kind of the explanation so I have enough time to actually go through everything with you. So that said, let's see how we can actually model these cards. So if we want to have a deck of cards, we need to figure out how each card actually looks like. Okay, so I made a suggestion that we want to have it look maybe like this, where it's an object with 2 properties, a card, which is the actual name of the card, for example, 2, 3, 4, or king, and then a suit, which is one of the 4 suits. And I mentioned that this is kind of what the deck of cards actually looks like, right? So in this case, we have 52 cards. Now, one way we could do this would be to hard code this from the start, right? So we could actually go in and manually make every single one of these objects and basically have like 52 different lines of code where each line is just a slight deviation kind of this right here, where we're kind of making, 2 of hearts, 2 of diamonds, 2 of clubs, etc. Now, I'm going to suggest that that is extremely tedious and definitely not very fun. And if we wanted to kind of modify that so that we could have many cards, many decks together, kind of like they might have in kind of a real casino, for example, where they have many decks together, like 4 or 5 decks, that would get really tedious very quickly. So we're going to try to automate that as much as possible. And we're going to look at these 2 parts to start. We want to be able to generate a random deck of cards where each deck each deck has 52 cards, and each card looks like this, right? It's an object with these 2 properties, where one property is the card and one property is the suit. So I'm going to pull up Visual Studio Code, and we're going to go ahead and kind of start with this. So I'm going to write this out as a outside of a function, I guess is the right way to kind of say this to start. And then I'm going to actually put this into a function afterwards, just so you can see how you can probably improve the code and make it more readable and reusable. Okay. So to start, we want to basically create a deck. And I mentioned that this is an array of objects. So let's create an empty deck to start. So I'm going to say const deck is equal to an empty array. Okay. And what we're going to do is we're going to fill this in with a bunch of cards. Now, how are we going to do this? So I mentioned that I wanted to create a kind of automated way to approach this, because what I don't want to do is I don't want to do this. I don't want to say deck.push. And I could do this like 52 times. I could say card is like king, for example, and then suit, I think I had an example, was hearts, right? I could do this 52 times, one for every single card. Now that would get really tedious, especially in future cases where if we had multiple decks kind of put together. So let's not do this. Let's find a way to automate this, because we know ahead of time all of the cards, and we also know all the suits. Right? So let's kind of list those out. Now I'm just going to copy and paste this for sake of not having you watch me type this out tediously. But I normally don't copy and paste code. But just so that you can kind of see what this looks like, this is kind of how I have these two variables set up. I have a suits, which is an array of strings with hearts, clubs, diamonds, and spades. And then I have cards, which is an array of strings as well, which is each of the actual names of the cards, 2 through 10, Jack, Queen, King, and then Ace. Okay, so nothing too fancy there, just arrays of strings to kind of enumerate out what we have in our deck. And this matches up with kind of this right here, right? Where we have these 52 cards. So if we were somehow to be able to combine these together and have 2 of hearts, 2 of clubs, 2 of diamonds, 2 of spades, 3 of hearts, 3 of clubs, 3 of diamonds, 3 of spades, etc., all the way to ace of hearts, ace of clubs, ace of diamonds, ace of spades, we would have 52 cards. Okay, so now what is a way that we can kind of go through an array of things like this, or a list of things, and do something with them in a more automated fashion, right? And that is usually a loop. Okay, so in some of the more recent videos, we saw kind of how a for of loops work. So I'm going to actually use that here to simplify this code a little bit. So I'm going to say for const card of cards. Oops, I can't spell here. This is going to create a loop where we're going to loop through every single card. So just to show you what this actually is going to be, I'm just going to console log this out. And I'm going to kind of open up my terminal here. And I'll show you what this actually looks like. So if I run node and I run blackjack.js, we'll see that I actually get each card printed out, right? Which is pretty simple based on kind of the previous loops that we've seen. So what do we want to do for each of these cards? We want to combine it with the suit, right? So we have 2 of hearts, 2 of clubs, 2 diamonds, 2 of spades. So each of these is going to have 4 cards, okay? And this is kind of the tricky part. How do we make it so for each card, we do 4 things? So the answer to that is just another loop. And this is where things get a bit gnarly, but let me show you kind of what this would look like. I'll say for const suit of suits. Now what we can do is we have a loop that's an outer loop that's looping through each card. So for example, 2. And then inside of that 2 loop, we're actually going through every single suit. So we're going to do 2 of hearts, 2 of clubs, 2 of diamonds, 2 of spades. So let me show you what that looks like. I'll do console.log of card and suit. And I'll just clear this out. This is going to go way off my screen, but hopefully you have an idea of kind of what that looks like. You can kind of see that we get this enumerated just like this, right? Wonderful. So the next thing that we need to do is kind of put this into a format where we can actually have those objects, right? So if you remember, we want to have something that looks like this. We want to have something that says the card, which is, for example, king, and then the suit, which is, for example, hearts, right? For every single card. We don't have to do this. There are many other ways to do this, but I want to show you kind of this way because I feel that it kind of makes more sense, especially as you start seeing the hands and it feels a bit more realistic. So inside of each of these inner loops where we're logging out the card and suit combination, right? So this inner loop is running 4 times for each of these numbers. We want to be able to push an object onto our deck that has a format that looks like this. So we can say deck.push, and we can push an object onto this deck that has a format of card, which is going to be the card, and then a suit, which is going to be the suit. Okay. So if we do this, let's see what we end up getting. What I'm going to do is I'm going to console.log the deck after this loop has finished constructing kind of these objects and pushing them onto the deck to see what we get. And look at that, right? We have our deck of cards. We have 2 hearts, 2 clubs, 2 diamonds, 2 spades, all the way down through all these other cards down here. This might get cut off by my face on the screen, but I hope you can see that that's actually how we would get a deck of cards. Now, this works because we know ahead of time exactly what the suits are and exactly what the cards are, so we can kind of loop through them in a fashion like this to actually get the actual deck. Okay, now, this is quite a bit of code. What I want to suggest is a way to actually clean this up and make it a bit more reusable. Now, I want you to imagine a situation where you were looking at this code for the very first time. Let's pretend you had no idea what this project is, and maybe your friend wrote this, or your coworker wrote this, or maybe even you wrote this several years ago, and you open up this file and you kind of take a look at this code. Right? Now, arguably, this code is not too crazy complicated because we can definitely get much hairier than this as we start building more complicated programs. But there's definitely a lot going on here, right? You'd have to probably read through all these and try to figure out what's happening and reconstruct it in your head. I'm going to make the argument that I would like to put this in a function. So as I mentioned here in our tips, I want to create something that looks like this. I want to create a generate deck function that will return to us a deck, which is this array of objects, right? Which is this array right here. Okay. So the easiest way to do this is to wrap this all in a function. So I'm going to use an arrow function for this. So I'm going to just say const generate deck is equal to an arrow function. I'm going to wrap all of this code inside of this function. Okay. So everything from here down to here is inside of this function. I'm going to get rid of this console log. And I'm just going to save this file so it formats a bit nicely. Okay. Next, what I'm going to do is I actually need to return this deck. Okay. So if that's confusing, take a look at the function video so you can kind of see how the return keyword works. But we want to basically construct this deck inside the function and then give it back out to whoever is calling this function. So we want to return this deck to the outside kind of scope or outside world so that we can actually have access to it. So what I'm going to do is I'm going to use Visual Studio Code to minimize this by clicking kind of this little arrow right here on line 1 for myself, and that minimizes this function. I'm going to then say const deck is equal to generate deck, and then I'm going to console.log out my deck, and I want to see if I get the same result. So if I run this now, it looks like we do get the same result, right? And I think that hopefully, if you look at this code, right, like I want you to imagine that you don't even look at the inside of generate deck, right? You have, maybe it's closed off like this, or maybe you just don't have time to read it, or you're skimming over it, right? If you read through this code, it's actually much easier to reason about than that previous chunk of code that we had before, because everything inside of this function, we can kind of see it's called the generate deck, so it has a pretty good name. So intuitively, we're kind of thinking maybe, okay, this generates a deck of cards potentially, and then we're storing this kind of on the deck variable. Okay, so the deck variable is pointing to this array right here of objects. Wonderful. Cool. So I'm going to get rid of that console log for now, and we're going to move over to the next kind of function. So I mentioned that once you have generate deck done, it would be kind of cool to be able to draw a card from this deck. Because if we look at the requirements, we want to, at the very start of the game, after we generate a deck, we want to deal 2 random cards from that deck to the player and to the dealer. Okay, so let's take a look at how we might do that. I'm going to create a function now because we're kind of used to how these functions will work just by seeing this. I'm going to call this draw card. So I'm going to say const draw card, and this is going to be a function, and it's going to do something. In this case, what we could do is we could refer to deck inside of this function. So we could say like deck dot push or whatever it is, or deck dot length inside of here. However, I want to kind of show you how this is not a good design for a function. And what we want to do is actually create this into a more like functional style and actually pass in the deck as an argument. So I'm going to ignore that for now, and I'll just show you how we could do this after the fact. But definitely keep in mind that this is not good design from the start. What I'm going to show you, we're going to change it shortly. Okay, so the first thing we need to do when we want to draw a card from this deck is to figure out how to grab something from this array randomly. Okay, so what does that mean? That means that this array has a length of 52. Okay, so if we generate a number between 0 and 51, we can use that number to pull out a random index from this array. So for example, if I generated the number 3, I could pull out this card right here, 0, 1, 2, 3, which is a 2 of spades. Okay, so we need a way to generate a number that's an integer, right, a whole number between 0 and then the length of the deck in this case, which is 52 minus 1, because we're starting at 0. So let's take a look at Google to see how we could do that. I'm just going to pull up Google here. I'm going to say JavaScript random number. Now my favorite documentation is MDN, so I'm actually going to go with this one right here, which is the Developer Mozilla Network. However, there's many other resources you can use that will be helpful, but I'll just go with that to start. And we can see that if I zoom in a little bit here, that we've seen this function before, but effectively math.random returns a floating point pseudo-random number between 0 and 1. So a fancy way of just saying a decimal number between 0 and 1. Okay, well, we don't really want that, right? We want a number between 0 and then some other number. Luckily for us, Mozilla here has a kind of a demo area where they created this function called getRandomInt with a max parameter, and they're doing math.floor of math.random multiplied by max. So let's see what happens if we actually use this. So they're saying if you use this, for example, with getRandomInt of 3, let me zoom in a little bit more here, then you should get 0, 1, or 2, right? So we get 0, 1, 1, 0, 2, 0, right? And if I change this number to say 30, then we should get a number between 0 and 30 or 29. And that seems to work. Cool. So it looks like we can kind of use code that looks like this to generate a number between 0 and some maximum number. Now let's take a look at what we have available to us. Math.random. This is available to us in JavaScript by default. So I'm just going to kind of close this function really quick. And out here, I'm just going to do a console.log of math.random. And I'm going to run this. And we're going to see what we get. Right? If I run this a few times, you can see that we get a random number between 0 and 1, which is exactly what we expect. All right? That's cool. So then they're saying we want to multiply that by a max number. Okay, so in our case, we want to go between 0 and 51. So is our max 52 or 51? Well, that might get confusing, but we'll see soon with math.floor how this might actually fix some of those problems. But in this case, let's just assume that I want to go from 0 to 52 or 51. And we can kind of deal with these off by ones later. All right, cool. So look at that. So we can have a random number that has a huge decimal to it, which is what we don't want. Between 0 and maybe 52, I'm guessing, right? Great. So it looks like it's randomly generating. So this math.floor, and if you were to actually Google for this, you can see that that effectively will just cut off the decimal portion, right? So if I go to Google again and I say math.floor JavaScript, what we can see is if we go to MDN web docs here, it takes a number and always rounds down and returns largest integer less than or equal to that number. So for example, if I run this code right here, you can see that 5.95 gets rounded down to 5, 5.05 to 5, etc., etc. Okay, we're not dealing with random negative numbers, so in this case, we don't have to deal with the kind of this funkiness over here, so we can stick with the positive numbers. Perfect. So that means we will actually never end up getting 52. We will always end up getting 51 as a max because the max we can ever get with this formula should be 51.99999. Okay, so between 0 and 51.9. Perfect. Now, the next thing that we need to do is round this down using that math.floor. So let's do that. So we'll do math.floor of this random number. So what we're saying here is we're giving this number, which are these numbers that we're generating, and we're generating that number, and we're giving that as an argument to the math.floor function, which will take that number and round it down and cut off the decimal place. Okay, so now if I run this, we'll see that we have the decimal eliminated, which is perfect. So what's cool about this is that we can use this as an index to actually get the values out of our deck, right? Because if our deck has 52 slots in it, we can generate numbers between 0 and 52 and kind of pull that out of the deck using that index. Okay, perfect. Next, what we're going to do is actually see how we can use this inside of our drawDeck function. So I'm going to say const random index. I'm going to take this code that we just wrote here. I'm going to cut it. I'm going to paste it over here. Okay. So I'm going to say I want to generate a random number between 0 and kind of 51.99999. And I want to chop off the decimal place. Now, I mentioned in previous videos that generally when you have numbers like this, you want to be very, very, very careful to hard code them, right? Because this is a very arbitrary number. A better way to actually get this is to actually use the dec.length, okay? And the reason is that now if the dec size changes, then this index will still update correctly and will not accidentally go over the dec size or under the dec size, okay? And we'll see how this will become useful later on once we start passing in the dec as a parameter. Now what we can do is with this random index, we can actually pull out a card from the dec. So we'll say const card is equal to, and we can pull out a number from the or pull out a card from the dec by using the dec and giving it that index, just like this. Okay. So if I console.log out this card, let's see what we get. Now I put this all in a function. So in order for this to actually log out, I actually have to call the function. And again, if that's a bit confusing, take a look at the function video. But this is just a function here. And the logic is inside the function. To actually execute this code inside the curly brackets, I have to call the function with this syntax right here. So if I do this, you see that I'm actually pulling out random cards from the dec, which is pretty awesome. Right? That's pretty cool. The tricky thing here, though, is that we could actually, if you really think about this logic, pull out the same card twice, right? Which is kind of a problem because we really don't want that to happen in a blackjack game, right? We want to have two different players have different cards so that we're actually reducing the numbers in the deck. So how do we kind of not only pull out the card from that index, but also delete it permanently from the deck? So let's go back to Google and we'll say, how do you delete an item from an array in JavaScript? All right. Now there's a whole bunch of resources for this. What you'll notice is that the documentation for MDN is a bit further down, right? This is tricky and this really depends on how complicated the question you ask ends up being. For example, what you'll commonly see is resources like this on Stack Overflow, where people will be asking very similar questions. It's a common question. And you might even get kind of answers like this. And it depends if MDN, for example, actually has that function even on it, or it's something much more complicated, whether you'll actually see the documentation for it on a resource like MDN. A lot of the time, you'll end up using other resources or blog posts to actually see how other people did it and kind of adjust the code to your own need. So luckily for us here, Google is saying you can kind of use these methods, it looks like. So you can use splice to remove an item from the arbitrary kind of item, shift from the beginning and pop from the end, which we've seen previously. And if I scroll down here, let's take a look at this. Let's take a look at array.prototype.splice. So I already knew ahead of hand from doing this several times that splice is kind of one of the potential methods. I always mix this up with slice. But let's take a look of JavaScript splice here from the MDN web documentation. I encourage you to read through these other ones that might pop up for you just to see if you see a similar answer pop up, just to get a handle on how that might look if you were to Google things for yourself as well. So for the array splice, it looks like it changes the contents of an array by removing or replacing the existing elements and or adding new elements in place. So this is a bit confusing. This basically in place means that, and this is what I mentioned earlier between getting confused by slice and splice, in place will permanently modify the array. So if this is confusing, definitely take a look at the array video where I kind of have a memory representation of how arrays work. But you can think of this as permanently changing that chunk of memory where the variable is pointing to and removing that index and shifting everything to match the new indexes. Okay. So let's look at some examples here. If I run this code that they have as an example, it looks like if we have this array of months, which is an array of strings, and we say splice from index 1, 0, and then Feb, whatever that means, then apparently this is going to insert something, which is not really what we want. In this case, they're inserting a number at this index, and over here, they're also inserting a number at this index. Okay, so for us, we don't really want to insert something, so this might actually not be as helpful. If you scroll down though, what you'll see is that they're actually using this syntax for splice right here, where they're actually deleting something from an index and then adding it back with a different value, right? Or in some cases, just not deleting anything and adding a value at that index as well, right? So what we want to do though is we just want to delete something, which is this syntax right here. We want to say splice starting at an index, deleting one item, and not adding anything into that place. So you can see if we look at this example right here with that in mind, this is saying start at index 4, delete one item from that index, but then they're using this syntax where they're adding an item back in, which is May. Okay, so in this case, they're effectively replacing an item at this index to actually get, in this case, I guess, June is being replaced by May. Right, so you can see June is being replaced by May because they're removing June and then adding May back in at the index. We don't want to do the adding part. We just want to do the deleting part. So let's go with this function right here. We're going to give it a starting index and a deleting count, which is going to be one item. And that should modify that array for us permanently so that now we have one less item in the array and everything gets shifted to match the new indices. So that's all a bit confusing. Let's see how that might work in practice. So here what we can do is we can say take the deck and splice it, and we want to start at the index that we want to start deleting from, which is our random index, because we already got the card out of that index and we want to delete one item from that index. Okay, so this is going to have the effect of deleting that card from that spot and then shifting all the cards after it up to match the new indices correctly so we don't have a gap inside of our array. All right. Then after this, we want to return the actual card that we actually generated here or pulled out of the deck so that we have access to it outside of this function. So let's see how this works. If I actually use this code right now, and I'll say const my card is equal to a draw card, and then I console.log out my card, what I hope will happen is that we're going to come into this function, we're going to generate a random number, we're going to go to the deck, pull out a card, we're going to permanently change the deck to remove that card from the deck so it can't be drawn again by shifting all the indexes as well, and then we're going to return the card that we pulled out just so that we have access to it. So what we hope to see is that this is going to be a card that gets drawn, and then if I also console.log out the deck.length, it should reduce in length by 1. So looks like that works perfectly fine. And I'm pulling out random cards from the deck, and the deck is indeed being reduced by a length of 1. Okay, if we didn't have the splice here, then this length would remain at 52, and we would not be pulling out cards from the deck. We would be actually leaving it in the deck and just pulling out a copy, basically. And we would always have 52 cards in the deck, and we might have duplicate cards being drawn. Okay, this is definitely a tricky function. Definitely take your time to actually kind of maybe rewatch this part and help you understand what's actually happening here. Now, I mentioned that I want to fix this code because I felt that kind of the way that we're using deck here wasn't the best. Now, this is a very, very small adjustment, and I want to actually make this take a parameter called deck, which we're going to pass in as an argument down here, and we're going to use this deck inside of the function instead. Okay, so this might look confusing because these have the same names. Okay, so I'll rename this as my deck just so you can see kind of the difference in how this actually might work. Now, and I'll change this to my deck.length down here. Okay, so in order for this card to actually generate now, we have to pass in the deck as an argument. And my deck is the deck that we created, right? So I'm creating a deck called my deck. And in order to draw a card, I have to give it the deck to draw from, which I'm going to pass in as an argument, and it will return to me a card and also modify that deck so that we can get something out of it. So if I run this code now, you'll see that we actually get the same kind of result. Now, this might seem like a small nitpick, but as your code gets larger and your functions get bigger, it definitely will help a lot having kind of this style of function where everything that's required for the function is kind of self-contained within the parameter list as well as the body of the function. If your function ends up needing things in the global scope or an outside scope that it doesn't necessarily have access to within its own scope, and we'll get into these topics later on because they're a little bit more advanced, you can end up having a lot of bugs in your code. So what effectively we want to do is force it so that this function has everything that it needs between here and here to do the job that it needs, right? Never in this code is it referring to anything out here. It's only kind of self-contained and independent. So as long as we give it a deck, it will take that deck and give us a card out of the deck. Okay, cool. So the next thing that we need to do is kind of the fun one. We want to be able to check the score. So I'm just going to kind of get rid of this right here. And I want to check a score given a hand, right? So if I go back to my tips, we can see that we have this here, which is what I kind of recommended, right? We wanted to check score given a hand, very similar to how we kind of drew a card given a deck, but in this case, this is slightly different because a hand is just a small deck that is for the player or for the dealer. Okay, so how do we go about this? Let's try to figure this out. So before we do this, let's see how a hand might even work in the first place. So to create a hand, we already have a deck, which is my deck. I'm just going to go ahead and create two hands, which are going to be arrays because they're just mini decks. So I'm going to say const player hand is equal to an array. I'm going to say const dealer hand is also equal to an array, just like that. Okay. And now what we can do is we can push onto this array two random cards. Okay. So instead of just dealing a card like this, I actually want to draw a card and push it onto each of these hands. Okay. So I'm actually going to get rid of this const because technically I don't need the card. And I'm going to say player hand dot push whatever comes back from this draw card. And I'm going to do that 2 times. I'm also going to do it 2 times for the dealer, just like this. Okay, so I'm going to draw a card from the deck, which gives us back that card value right here. And it's going to be pushed onto the player hand twice, and then same with dealer hand. So our deck, if we console log out a few things here. So if I console.log out the player hand and the dealer hand, as well as the myDeck.length, what we'll hopefully have is a length of 42 because we've dealt 4 cards and permanently removed them, right, using splice from the deck. And each hand should have 2 cards randomly drawn from that deck, and there should be no duplicates because we're removing cards from the deck. So let's take a look if that's true. And looks like it is, right? We have the player hand right here, which has an 8 of hearts and a 6 of clubs, and you might get different results because this is always randomized. And then the dealer hand right here, which is a 5 of diamonds and a queen of diamonds as well. And then the length of our deck is 48. Look at that, right? 4 cards removed from the deck. So that's perfect. Now I'm going to just comment this out for now, and we'll come back to actually logging a bit later. I'm also going to kind of minimize this draw card function just so that we have a bit more space on the screen. All right. So in order to check the score, we want to be able to take a hand, which is an array that looks like this, and calculate kind of the points in that hand. So for example, if we look at this hand right here, and this is where it gets really important to make sure you understand the requirements before you actually try to put this into code, right? I have an 8 of hearts and a 6 of clubs. So the most important thing to me is the 8 and the 6. And if I add them together, I get 14 points. Okay, so down here for the dealer, I have a 5 and I have a queen, right? And if I add those together, since the queen is worth 10, I have 15 points, right? So if we look at the requirements here, these are the point breakdown. Queen, king, jack are all 10. All the other cards from 2 to 10 are the actual values, and the ace is worth 1. Okay, So if I kind of rerun this one more time, if I have a 2 and a 10, this is 12 points. If I have a 4 and an ace, this would be 5 points in this case. If you want to be fancier and kind of make this more tricky and a bonus for yourself, you can try to figure out how you can make this worth 11 or 1, whichever gives you more points without going over. But we'll stick with 1 to start. So let's actually code out this function. I'm going to call this check score. And I'm going to say that this function, as I mentioned, is going to take a hand and give us back that score. So this is going to take a hand. And we want to return back a number, which is the kind of numbers in that hand added up together, but also depending on if it's like one of these face cards or an ace. Okay, so I'm going to create a total number. And I'm going to start this at 0. So I can loop through that hand and figure out how many points are in that hand. So I'm going to say for each card, const card of the hand, let's see if I can log out, what is that? Composition event, console.log the card, just to see kind of what's in there, to make sure that we're doing the right thing. So if I say check score and I give it the player hand, what I want to happen is I know that I've pushed 2 cards onto the player hand, and I want to check score of that player hand with this function where I'm going to log each card inside of that hand. So I should see kind of these 2 individual objects being logged out inside of that hand. So let's see what happens. There we go. So I get a 7 of clubs, a 7 of hearts in the player hand, 5 of clubs, 7 of diamonds. So what we want to do is we want to pull out this card value and kind of add it to this total and return that number, right? So this is going to be kind of a bit odd because of the naming that I used. So this is an object, right? Each card is an object. So this might be better if I say card object, just like that. And this would be card object, right? But I want to pull out the card property, right? So if I console log out card object dot card, I'm asking for just the card value, right? So if I do this, I get 6, 9, I get Jack 5, I get Queen, King, right? So now we can get closer to actually counting up the points. This is 15 points, this is 15 points, and this is 20 points. Okay. So how do we actually go about counting these? Because it's not as simple as just kind of adding these numbers, because we can't take Queen, for example, and add it to the total because Queen is not a number. So let's figure this out. So we want to write out, check if it's a Jack, Queen, King, check if it's an ace, or otherwise it's 2 to 10. Okay. So we want to kind of deal with these 3 scenarios because we have it coded such that Queen and King and Ace are all actually different values. So let's see how this works. We'll say if card object dot card is equal to King, right? Then we want to say total is going to go up by 10. So I'm going to copy this a few times, and I'm going to do this for Queen, and I'm going to do this for Jack. All right. So we're saying if the card has a card property that's a King, Queen, or Jack, then we get 10 points. We want to do the same thing here. So we're going to say if card object dot card is equal to Ace, but in this case, for an ace, we only want to add 1 point. Right? However, now we're in an interesting spot where we want to add 2 to 10 are the actual numbers themselves. So can we do kind of like an else? Else total plus equals the actual number itself, like this. So it turns out that this is actually not going to work because this else is attached to this if statement. Okay, so if you are confused about this part, I definitely encourage you to take a look at the kind of conditional statements video where we kind of go through this in a bit more depth. There's another kind of construct called the switch statement, which we'll go through later, that might make this a bit easier as well. But for now, we'll stick with an if, else if kind of setup. So I'm going to say else if for this. I'm going to say else if for this. I'm going to say else if for this as well. And I'm going to say else at the end. So now I've created this into kind of one big construct where only one match can happen. Is it a king? You get 10. No? Well, then is it a queen? You get 10. No? Well, is it a jack? You get 10. If it's not any of those, then we're going to check for ace. You get 1. And if it's none of those, queen, jack, king, or ace, then it must be the 2 to 10. And you get the actual card value back out, like one of these, for example. Okay. Then I want to just log out this total to see kind of what we get. So at the very end of this function, I want to console.log out total. Okay, so let's see what happens if I do this. Oh my goodness, craziness. What is happening? So if you spot the bug here, good on you. This is actually quite a tricky one. The reason this is happening is that we actually have our deck. If you take a look, where is my generate deck? All of these numbers here, 2 to 10, are strings. Okay, and if you add a string to a number, then you'll actually get back kind of those things concatenated to each other. So for example, what's actually happening here, if I do something like this, if I comment that out and I say console.log and I say 10 plus 10 like this, right? You can see I get 10, 10, which is not what we want. We want to turn this 10 into a number. So let's take a look at how we would do that. I'm going to go to Google and I'm going to say JavaScript string to number. All right. So if I scroll through here, it looks like there is kind of some documentation on how to actually do this on MDN potentially. So if I look at this, it looks like there is a parse int function that seems to be built in. And if I give it a number, it looks like it might actually turn it into kind of the integer representation. It has all this extra funky functionality that is a bit tricky, but we just want to give it a string and it'll give us back the actual number. So you can see that the string starting with an integer is a parameter, and then the return value is an integer given that string, or nan when it's not parsable. So for example, if we were to look at other kind of resources, for example, Stack Overflow, I'll just pull this up just for sake of example. You can see that generally the setup for things like this is people will ask a question just like we have, and then there'll be kind of upvoted answers very similar to this. And it looks like, oh, there's 2 different ways that these guys use. They have a number that we can do like this, or they have that parse int, which is what we saw ourselves earlier. So what I'll do is, you know what, I'll try this out just for a change. I'll see if this actually works. We can use the number function to actually turn the string 1000 into the number 1000. So they're saying if we do number like this, and we kind of pass that as a function to the string, and I kind of run this, oh, look at that. Now we get the number 20. All right, so what we want to do is this situation right here, the 2s to 10s, right? These ones. We want to make sure that those are turned into a number before we add them to total. Otherwise, they're going to be added as a string. So we want to say, turn this into a number and then add it to the total. Okay. So now if I rerun this code, you'll see that I get 2 points, 20 points, 19 points, 20 points, 19 points, 12 points, 8 points, 20 points, right? And that seems to kind of work, hopefully, as expected. So if I console.log out the player hand as well, let's see what we actually get here. So if I have a king and a king, I get 20. If I have a 10 and an ace, I get 11. If I have a 4 and a 10, I get 14. Seems to be working correctly. Perfect. Oh man, that's a lot of stuff. So we have so far the ability to generate a deck, draw a card from the deck randomly, check a score given a hand. So we have a lot of the building blocks ready. The only thing we have left to do is to create the actual game loop, right? To create, in this case, what I mentioned was an infinite loop where we're doing dealing to a player, checking to see if they go over 21 or hit 21, And then if not, then doing the same with the dealer and just keeping looping until one of these conditions ends up happening. So let's actually get to coding that part. So if we kind of close this off, I'm just going to get rid of this down here. What we want to do now is create this infinite while loop. So I'm going to say while true. And there are many ways to create this loop. It doesn't have to be an infinite while loop. I'm just going to show you one way to do this and kind of mentions a few other ways towards the end as well. So inside of here, we want to do this. We want to deal the player card. We want to check if the player bust. We want to check if player hits 21, right? And bust is like over 21. We want to do the same here for the dealer as well. Okay, so over here, we want to do the same thing, but for the dealer. Okay. So how do we deal the player a card? Well, we can take the player hand and we can push onto it whatever we get back from draw card using my deck. Okay, so we saw that this is the same as this. When we initially drew 2 cards for the player and for the dealer, we had this code right here, 2 lines for the player, 2 lines for the dealer to draw them 2 cards each at the start. This is absolutely no different. This is the nice thing about creating reusable functions, is that now that we've created this kind of building block functionality, we can actually reuse this code again and again and again, and it'll work the same way without us having to worry about kind of copying and pasting it or changing it slightly. Okay. Then what we want to do is we want to check to see if the player has gone over 21 or hit exactly 21. So in order to do that, we need to know what score the player actually has. Okay, so I'm going to say const player score is equal to, I'm going to call my check score function, and the check score function takes the hand, which is going to be the player hand, and this is going to give us back a score. So we want to see if this score is over 21, right? So we're going to say if the player score is greater than 21, then we have bust, right? And then we lose. So we're going to say console.log. I'm going to use a template string here so I can put a bunch of kind of typing and text in here. I'm going to just say you lose, right? Very nice text. Your final score was, I'm going to put in the actual score here, which is player score. And I'm going to say while the dealer, I'll put this on a separate line, while the dealer had, and then I'm going to put a $sign and then something here for the dealer score. So for the dealer score, we don't actually have this yet, right? So I kind of mentioned in my slides before that I wanted to kind of see what the dealer had and what the player had at the end score-wise. So I wanted to say kind of your score was this, dealer score was this, whether you won or you lost. So what we kind of need to do is generate both the scores for the dealer and for the player, right? So let's try that. So we'll say I'm going to do a let here, dealer score is equal to check the score of the dealer hand. And this is before the dealer gets played another card. Okay, so only the player has been dealt a card because the player goes first in this version of our game. And over here, we can use the dealer score inside of our template string to actually log out both of their scores together. Okay. Most importantly, what we want to do is we want to break out of this code if we hit this condition, right? So if the player goes over 21, then the dealer immediately wins. Okay, the player loses, in this case, you being the player. Okay, so this is definitely a bit tricky right here, right? Checking to see both scores because that was just how I had it in the demo screen. But if you didn't do that, that's also totally fine. The main thing is that you're kind of understanding this logic as we're going along. Next thing we want to do is check to see if the player hits 21. So we're going to say if the player score is exactly 21, right? Exactly equal to 21, equals in JavaScript. Then we want to do something similar. We want to console.log, and we want to say you win. And we'll say your final score was, and then we'll do the same thing, player score, and I'll say while the dealer had, and then dealer score. And just like we had earlier, we want to break as well, right? So if we have exactly 21, the dealer doesn't even get a chance to check their card or draw a card. The player immediately wins. Okay, definitely not how real blackjack works, but just a simplified case, just so that we can separate out the turn, so one can go and then the next can go without actually making it more complicated for our logic. All right, so just to kind of recap this, we're dealing a card to the player. We're calculating the score for that player. We're calculating the score for the dealer's hand. So at this point, the player actually has the new card, an extra card, and the dealer still has their old hand. They haven't gotten a new card yet. So we're going to check to see if the player got over 21. And if they did, then they lost, right? Because the dealer won in this case, because the player kind of went bust. And if they have exactly 21, then the player wins. So in this case, the player has a slight, advantage, you can say, because they get to go first. Okay. So if neither of these conditions are true, right? If we don't go over 21, or if we don't get exactly 21, then we do the same thing, but for the dealer, right? So let's go ahead and do that. So the dealer is now going to get dealt a card. So we're going to say dealer hand dot push. And we're going to draw a card from our deck. So same as this, but with the dealer hand. And we want to check to see if the dealer met any of these conditions. Did they go over 21, or were they exactly 21? So we need to recalculate the dealer score. This is why I used a let up here, because now I want to kind of assign a new value to dealer score after the dealer has been pushed a new card to their hand. So I'm going to say dealer score is equal to check the score of the dealer hand. And I'm going to get back a score value that's going to be a number inside of dealer score. Okay. Now we can do these checks. I'm going to say if the dealer score is greater than 21, then we're going to do a log. I'm going to copy this log from here just so you don't have to watch me type, as well as the break. And if the dealer score is greater than 21, then you actually win. Right? And then we can log out the scores, the player score as well as the dealer score. If the dealer score is exactly equal to 21, then I'm going to paste this as well. Then I'm going to say that the player loses, which is you, and then we're going to log out the scores, and we're going to break it out as well. Okay, so there's a lot of repetitive code in here, right? This if statement, this if statement, this if statement, this if statement, all very similar. Checking the scores are okay because we're using functions. Drawing the cards, kind of a bit of repetition here. Let's just see if this works. Then I'm going to kind of note a few areas for improvements and then actually kind of get the final logs going before we have this video run too long. So if at the very end of this, after the loop, I say the ending player hand is player hand, and I'll just duplicate this a few times, ending player score. And I'm going to say this is going to be check score of the player hand. And then this is the ending dealer hand. This is the dealer hand. And then ending dealer score is going to be the check score of the dealer hand. Okay, so this was just part of the requirements. We wanted to log the ending scores and hands for the player as well as the dealer. So we can check the hands just like this by logging out the array, as well as passing in the array to the check score function to actually get the score back out for both the player and the dealer. And we'll do that once at the beginning as well, where we'll say, where was it? Starting. I'll just kind of copy this right here. Say copy. Come back up here. Lots of back and forth, and I'll change these to starting. Okay, so starting player hand, starting player score, starting dealer hand, starting dealer score. All right, now that was a lot of back and forth, a lot of code. I definitely did not expect you to actually keep up with that the first time around. And if you did, well done, pat yourself on the back, but definitely not expected to keep up the first time around. I should also mention again one more time, this is my way of doing it. Not the best way. There's many improvements we can make, which I'll mention shortly, but let's just see if this even works in the first place. So if I run this, I get an error, which is cannot access check score before initialization. And that's because with the way that these functions are created, we actually have to have these variables declared as arrow functions before we actually use them. So if I take this code here, I have to cut this function and I have to paste it up here where I can have it declared before it's used, right? So in fact, the best kind of approach to this, oh my goodness, the best approach to this is to actually take all of our code like this one here, where we're actually using our functions, cut it and put it after our function declarations like this. In this case, these are not really function declarations. These are arrow functions right up here. And if we were to use the function syntax, where, for example, we were to do this function generate deck, for example, and then have our code in there, we would not have to really worry about having these first. But we're just going to use arrow functions because as we get into future kind of courses where we look at things like React, for example, or front-end techniques, this is going to be a bit more common of a pattern. So we'll just get used to actually declaring these functions at the start. Okay, so I just moved my code around. I have generate deck, draw card, and check score at the start. Then I can actually use these functions down here. I'm creating my deck. I have my hands, and then I can draw from the deck down here. Cool, so we're in the home stretch. Let's see if this actually works by running this code now that we've made that change. So I'll just clear out this error, fingers crossed. Let's see if we have any more errors. I run this, and okay, I have a bunch of logs. Oh no, I still have one error here. This is cannot read property card of undefined. I think I have an idea of why that is actually. I remember really quick. Inside our check score function, at the very end, we just console log out the total. I forgot to actually return the score, return the total, sorry. So our check score is expecting these scores to actually be numbers that are returned back out. In this case, if you remember from the functions video, if we don't return anything from a function, we're actually returning undefined. So we're actually getting undefined right here. If you see for the scores, which is not what we want, we actually want the real scores. So we actually have to return the score back out of the function so that we can actually calculate it properly. I'm also going to get rid of this console log just so it doesn't clutter up my screen inside the check score function. So if you're getting that error, that's just because of this total not being returned here. I'm going to leave these errors in again, just like a couple other videos, just so you can see that a couple of things do happen. Even though I have the code, I still make a lot of these errors as we're coding it together, and it's a very common thing that happens. So that said, I'll just close this off. Now finally, hopefully, fingers crossed, if I clear out my console, let's see what we get. And oh my gosh, look at that. That's amazing. So I get the starting player hand, the starting player score, starting dealer hand, starting dealer score, and then the game loops around, and we could kind of log out the player hand and dealer hand as each kind of turn passes. But eventually, in this case, it looks like the player, as we won in this case, because we had this hand, we had an ace, a 4, and a 10, so we had 15, and the dealer, I guess, got a bit greedy, and they tried to actually draw after they had 16, and they dealt a 7, which made them go over 21. So I'm going to run this one more time. Let's see what we get. A little bit more code here, but still stays on my screen. You can see that in this case we won again. We beat the dealer, and the dealer went a little bit overboard again as well. So pretty fun, right? There is a lot of stuff happening here. Okay, so to wrap up this video, I just kind of want to mention that, like, as you're building this, right, I 100% would never expect you to get this solution. This is my personal solution. I actually had a few other solutions and I didn't like them, so I kind of refactored a little bit to get to this solution. Even this solution is not something that I probably would want to put out if I wanted to be really perfectionist about it, because you can see that I kind of followed a good pattern here where I had a bunch of functions to do things, but then down here I kind of have just a bunch of code dumped out. Maybe I could put this in a function to clean things up. Also, a lot of this code is there's a lot of duplicate code here. I don't really like that. I could probably put those in functions as well, right? It's always a delicate balance between what you put in functions that's reusable and just makes it easier to kind of read and reason about in your kind of code. But in general, I just wanted to show you kind of a few strategies you can use, a little bit of messy code, a little bit of cleaner code, just so you can kind of pick and choose from what you want, as well as see some of the errors that we went through together. So to kind of finish off, this is definitely a challenging project, right? Even though it seems pretty simple, there's just a lot happening and a lot of chance for bugs and errors. As the projects that we work on together throughout this series get more challenging, this is increasingly going to become the case, right? There's just going to be constant bashing our head against the wall, constant frustration, constant bugs. Maybe you missed a semicolon, maybe you missed a bracket, maybe you missed like a dot or something. You even saw me have a few of these bugs, right? And that is totally normal. Don't get frustrated as you're building out these projects yourself. Treat it as part of the learning process. And I mentioned a few extra tips about that as well in the previous video where we set up this project together conceptually. Okay, so I hope you enjoyed that video. I know it ran a little bit long, but I just really wanted to show you kind of the process of building out a project like this, especially a little bit of a bigger one, kind of from start to finish, as I would have done it kind of myself. What we're going to do in the coming videos is we're going to kind of get back to JavaScript syntax, and we're going to look at a lot of the more kind of intermediate and newer features of the language that allow us to do a lot of fancier things and kind of more modern things with development that'll give us a really, really good head start before we start going into technologies like front-end development or back-end development using JavaScript. So in the next video, what we're going to do is we're going to look at one of my favorite, I know I say that about everything, but it really, really is one of my favorite tools in JavaScript, which is called promises. And this is the idea of being able to kind of run code what's called asynchronously in the future. And we can kind of have code intertwined where some runs right now, some runs in the future. And this sounds like a totally mind-bending concept, which it kind of is, but really one of the more fun and powerful parts of JavaScript. So I really, really can't wait to get to that. I have some beautiful drawings to share with you as well on that one. So I encourage you to kind of go through this video, get more practice, kind of make sure you understand at least different parts of it as best as you can. It doesn't have to be 100% basic completion of this video. If you found this project valuable, I would love it if you could like the video and subscribe to the channel. I'd love to hear in the comments different solutions that you came up with, whether they're different functions or different ways about thinking of this problem. This is something really where you can come up with ample different solutions compared to mine. What we're going to do in the next video is we're going to go through that idea of promises together. We're going to go through a bunch of beautiful drawings that I made up for it. But I can't wait to kind of explain the theory of promises and then get into some exercises for that as well. So once you're comfortable with this, I will see you in those videos.